Well, thanks everyone for joining and all the good mornings. I can see the chat there. It's not like the conventional conference, so I would say hello to you all too if I could in person. But yeah, I'm excited to be here. This is it's great to be part of the conference this year. So I'm going to be talking about the MOTUS wildlife tracking system in the Atlantic region, more specifically during this talk today, as Daniel had mentioned. So thanks for the intro. And I just wanted to start by sort of clearing the air and sort of tell you MOTUS is Latin for movement, if anyone's wondering. That's what it is. It's just it's not an acronym or anything, but it's kind of becoming more recognized as something that a solution to one of the problem of tracking small animals over really vast distances and over their entire annual cycle. So I feel like to really emphasize what MOTUS is and how it's important, we need to sort of step back and talk about how we got here and what the context it sits within. So the first real question is, how do we know where animals go, right? Because I know you can think about like smaller animals, like land-based animals. They're a little more straightforward to track. You can just follow them around. There's definitely challenges there involved, but really when it comes to flying animals or swimming animals, we're not at all capable of following them anywhere. So we have to employ these different methods to figure out where they're going. And before with any kind of technology, we would just sort of make these assumptions based on, oh, the birds are leaving for the winter, and then they're showing up somewhere else around the same time. So maybe those are the same birds, right? And it's not a terrible conclusion to make, but it's lacking in information, and you can only go so far with it. So the next thing to do is, well, you can actually put these unique metal rings on the animals, and you can those metal rings have a number stamped in them, and if you ever see the animal again and catch it, you can read out the number on that metal ring and tell which animal it was that you saw. And this works well. It's still used today. This is the banding operations with birds. It's done with bats. They put stickers on butterflies. But the challenge is there is that you have to have an observer again. Wherever you want to know where it went, you need to have an observer. With the metal rings, you need to catch the animal and then read out the metal ring. And obviously that requires a lot of training. So there's a limit there. And actually the probability of getting any kind of observation after you first put that ring on the animal is pretty small. So one way to help increase the chance of someone spotting that individual again is you put the colored rings on the animal so that you can actually identify it. Sometimes they're numbered, like a goose with a big number tag on its neck, so that anyone sees it, they can actually report the numbers or report the combination of colors. And this is actually being done right now with the Ipswich sparrow project. For those of you who aren't aware, the Ipswich sparrow is a subspecies of the savanna sparrow that only breeds on Sable Island. So it's an interesting population that we can actually study by doing this color band work, where you put a unique combination of colored bands, and if anyone sees them, they can report them to us. And we've asked people to photograph them and send us their photographs. And so this has been done over the past few years. With Sydney Bliss was leading this one, and they've had over 200 resightings of these animals, all the way down to Cape Hatteras in North Carolina, where they're the far reaches of their wintering grounds. And so this is really valuable, and we use this information still. This is an ongoing project, but when you think of it, 200 sightings out of over 1,000 birds being color banded is not a lot of data for what you're putting into it. Even though the bands are basically pennies each, and you can put out 100 in a couple of weeks, or several hundred in a couple of weeks, it's still not, you're not getting a lot of data out of that. So there's limitations, yet it helps, it helps us get somewhere that we weren't able to get before. And see, these are the what it looks like on the butterflies or bats. So as you can imagine, everyone's got like their smartphones now, right? There's got to be some other technology here we can use, right? And probably the first thing that comes to people to mind is satellites, and I'm sure many of you have heard about satellite tracking. Well, yes, it is a thing. We do use satellites to track flying animals. I'm not talking about swimming animals in this talk because I don't know anything very much, at least, about that. So this is restricted to flying animals, really. And so satellites are really, really useful for sure, because basically you can get a detection of an animal anywhere in the globe potentially, except for maybe the far reaches of the north, the Arctic and the Antarctic. But really, you can get it anywhere over the ocean. You can see in this map on the right-hand side where there's all kinds of detections across the Atlantic where these peregrine falcons went. And so in this particular study, they tagged with something like 30 peregrine falcons on 2 islands in the northeast United States. And they could track these movements. And you can see like there's this one track in blue that sort of make these really long geometric lines far into the Atlantic. And it doesn't seem that natural, but if you map that against shipping routes, it actually lines up almost perfectly. And it turns out they think that this peregrine falcon is actually hunting off of container ships and then hopping onto different container ships as it's to keep itself in the Atlantic. And then more cool information that you can get from this map. If you look around the Bahamas, just next to Florida and north of Cuba, there's this sort of dense cluster of detections right there, and that's where they think the bird actually died and was drifting in the ocean currents for several days. And so, like this kind of data, as you can imagine, there's no possibility of getting this with just putting bands on the bird, right? So it's really satellites that are the beauty here in getting this kind of data that you wouldn't otherwise be able to get. The downside is that unfortunately you can't put these on small birds. They're actually quite heavy. They don't get small enough to put on small birds. Basically, almost all the passerines, all the bats, and all the insects can't use satellite tags. So we're still stuck at square one here. We don't have this solution, this beautiful solution for our small songbirds. And the other thing too, these are very expensive. So big birds have higher survivorship. We don't want to be putting out 30 of these on small little songbirds that might just we might get no data from when they cost thousands of dollars a piece. Anyways, so what we can do? What can we do with that? Well, radar is actually a really great resource right now. It's widely being used in a lot of research because you can get this snapshot of the entire continent basically any given time of live migration across the continent. So the way it works, the radar was developed in World War II. It's been around a long time, and all you're doing is selecting for a certain sized water body. And birds have a lot of water in them, so you can just sort of choose a body size that's around approximately what you'd expect for birds, and then select, and then you actually detect. You can filter out all of the rain, precipitation that radar normally are used to detect. And so what the map you see is on the left is a live bird migration map that's being created, and you can see, you might be able to see some arrows in there. Those are actually direction of movement that's being detected using the Doppler shift in the data sets. So this is a really amazing kind of research that's been used to actually, one paper has looked at light pollution and correlation of these movements around cities. So it's actually quite interesting for these broad scale kind of analyses. And you can also create forecast maps. So they create weather models, and then you can model where the birds are going to go based on previous data and weather models. So again, really great stuff. You can't do this with any other kind of technology, but you're not actually detecting individual animals here. You're detecting sort of clouds of animals, the big moving flocks, or just like masses over of thousands of birds in any given location. So so you're not able to track individuals across any given distance, and you're not able to tell a species apart. You can only say if it's a big animal or a small animal. So those are really the limitations here. But again, a very useful tool. That doesn't mean it's being widely used right now. It's just for certain specific applications. So for small birds, we really just have these light level geolocators, or we had for the longest time. These are developed in the early 2000s, and they just are light sensors with a clock. So it just tells you when the sun rises and when the sunset is, and with that you can sort of figure out what time the solar noon is, and the day length. And that gives you a longitude and latitude. And it's actually really great. There's issues with like precision when you get to more northern and southern latitudes, but it's still really, really valuable because these geolocators get to be down to just under half a gram. So you can put them on birds like this Swainson's thrush, but also some warblers as well. The downside with these is that unfortunately all that data is there's no transmitter on it, so all that data is just being stored on the device. So you kind of back to the banding issue where you have to catch the animal again to get all your data. And so that means that you have to set up all your studies so that you're going to be able to reasonably catch a bunch of your animals again to get your data. It's better than banding because you're getting a whole lot of data about where it's been between the two times that you had it in your hands. So that's really great. But unfortunately, you're still eliminating a lot of potential research there because you need to catch the animal again. And even with those studies that are designed with that assumption that you're going to catch it again, your probability of doing that is like 1 in 5. For every 5 tags you put out, you only get 1 back. So yeah, this was all that was available for smaller songbirds, though, for quite a while. Until more recently, we had the GPS tags now, and these are basically the same idea. Not to go too much into this, but these are just like the GPS on your phone. It's logging GPS locations on the tag itself. So you have to catch the animal again, and then download the data. So the same kind of problem with geolocators, but you don't have the issue where you're relying on sunlight to get your data, right? So it's kind of makes it more feasible for bats and nocturnal animals, and also animals like to be under thick canopies. But still, you have to catch the animal again. So really, the only thing left that we have to work with where you don't have to catch the animal is radio transmitters. And so I'm sure most of you are kind of aware, have an intuitive sense of what this is. It's just a device that emits a radio signal, and they're almost, most of them are battery operated, but some are solar powered, and they can go down. It gets as small as 0.2 grams, so they can be put on things like dragonflies and butterflies and bumblebees. So that's really incredible, these little devices. But unfortunately, it doesn't collect data, right? It's only sending out a signal. So you need some other device to collect the data for you, and that's going to be a radio receiver, just kind of like your car stereo. But the problem is you're going to have your receiver wherever you want to know what the bird was or the animal was. So what's been done in the past is people would go around with these antennas and a handheld receiver and sort of walk around and try to figure out where the animal is. Sometimes you can track it down and actually see it, and then you say, okay, it's in this location. So you can also take a car and drive around and be like, oh, I've detected it roughly in these locations. But still, you're really limited to this narrow geographic area where you want to make detections. Another option is to have this stationary receiver, where you just set up a receiver in places where you think they might pass by, so that you don't have to be there, and you can just be there logging data automatically while you're gone. And that's actually really great and convenient. So these particular receivers have about a 20-kilometer range, so you don't need to put up a heck of a lot, but you do need to put up several if you're going to be doing a broad scale analysis. And these things don't come cheap, right? They're actually about the receiver computer itself is like $5,000. The whole station would be like $10,000 each. So if you really want to do a broad scale study, you're going to need a big budget. And that's not something that wildlife biologists normally have. So it's really like, it's sort of this cost, what kind of cost can we afford, and what kind of technology exists that we can use to do our studies. And really the limiting factor here is that we don't have the ability to do broad scale studies with radiotelemetry, because it just is too the cost is prohibitive. So Phil Taylor at Acadia University sort of came up with this idea of like, well, what if we make our own receiver? And what if we just share our data? So what if we share all the receivers instead of all being, every man for their own? We can all share this data set so that we don't all each have to pay for our own receivers. So the first idea of building a low-cost receiver was a huge endeavor, but luckily he had a genius with him, John Vrostovsky, who designed this computer. He programmed it with something like 7 different programming languages. It's cross-disciplinary. This is a really an amazing thing that it actually was accomplished. But essentially, he managed to pare down the cost of the station from about $5,000 down to $1,500 a piece. So that makes you more than triple the amount of possible receivers that you can put out on the same budget. So that was one of the great ideas that Phil Taylor came up with, and that John developed. But then there's another problem here. It's that these tags, these transmitters, one thing I didn't mention is that they're all emitting a signal on the same frequency, right? So everybody in any place of the world could be, or not in the world, but North America, we can be hearing the same tags. But we have to be able to tell each other's transmitters apart from each other. If one person puts a transmitter on a bird in northern Nova Scotia, another one puts it on a bird in southern Nova Scotia, you want to be able to tell those apart if they're going to be detected somewhere far down their migratory path in, say, Maine or New Jersey. So these tags actually emit digital signals that encodes a unique ID. This is like in this example, I have the number 123. But that unique ID that's being sent out is only a limited number of them. It's just about 500. So if we are to create this really great network of shared receivers, we're only going to be able to have 500 transmitters out at any given time. So it kind of, again, limits you a lot. And so that's, again, where Phil sort of came up with this great idea of, well, what if we sort of differ the amount of time that each tag is emitting a signal? Because the way the signal is emitted, it's sort of like saying, I'm 123, I'm 123. It's sort of like periodically emitting a signal, right? And that period of time between each signal that it emits is unique to the tag. So the top tag in this example is emitting a signal every 3 seconds. The middle one every 5 seconds. The bottom one every 7 seconds. So by differing that time, you can actually tell these different tags apart from each other. And then you all of a sudden start multiplying the possible number of unique tags that can be out there. And right now, although there's just 500 unique tag signals that are being emitted, sorry about that, there are, even though it's just 500 unique tag IDs, there's about 50 unique timings between, or time intervals. So that sort of multiplies the possible number of tags to something like 1,500 or 25,000 unique IDs. So all of a sudden we have, okay, that's more reasonable. We don't really need more than 25,000 transmitters out at any given time. This can be a global network. So just remember, we're having one receiver picking up 3 different tags at the same time, and we can tell them all apart from each other. And that's really, really critical for this technology. And part of the challenge here is processing the data too, because now that we've developed this new receiver, we've also developed a new method for creating new identifiers for the tags. We have to also develop a method for processing the data. And that's, again, where John's genius comes in. He developed this really complex algorithm to decode all of the signals and figure all that out so that all the researchers can get their data. And so this is what the end result is. We have radio receivers all around the globe. We also have transmitters being released on animals all around the globe. And say somebody tags a red knot in the southern tip of South America, they can have that bird being detected anywhere along its migration path on the receivers there, and that researcher will be able to get their data because of other researchers in other parts of the globe. And so that's the beauty of MOTUS, really. That's kind of what people are so excited about, is that all of a sudden now we can research these small birds across the whole globe because of this facilitated research, because of all of these collaborations occurring between researchers. So take a bit of a breath there. Hopefully that gives some idea of what's going on, but I just want to give you a sense of where we're at right now. We have been growing quite steadily since it first began in 2013. MOTUS was sort of taken on by Birds Canada in 2016. So you can see in this plots on the right that the number of stations and tags and projects that exist have been growing quite steadily every year. Right now we have about 25,000 animals have been tagged. Almost 1,000 receiver stations globally, over 100 projects, and nearly 900 partners involved. So this 31 countries. This is really, really huge, and it exploded really quite quickly. More locally, we have 86 receivers in Atlantic Canada. 3 different project coordinators are responsible for those stations. But you can see there's quite an array in the blue dots there. You can see there's quite an array just west of us in other parts of North America. So if you're going to be releasing tags in Nova Scotia, you'll certainly get a lot of detections outside of the province as well. But right now, this year, we've got a small concentration of tags being released all around this sort of Chignecto-Tintamar region. Most of those are going to be Julie Paquette, Diana Hamilton's shorebirds that they're tagging right now. But some of them is Kirk Guglielmo, University of Western Ontario. They're looking at stopover behavior of songbirds in New Brunswick, which is Andrew Beauchamp, who's the PhD student right now. And so there's not very much seemingly go on, but this is last year. There were 7 projects, so it's really it speaks about our times a bit, what's going on this year. It's, even though we're quite privileged being here in the Maritimes, I think it's still limiting the research that can be done just because of the pandemic. So it's important to be aware of that. So I want to talk about just briefly about what kind of research we've seen as a result of the work that can be facilitated by MOTUS. And I want to talk about ipswich sparrows. Remember, that's the subspecies that only nests on Sable Island. And I would have liked to talk about shorebirds more, but I'm not really that experienced with them personally. I'm more of a passerine biologist. So, and ipswich sparrow is something that's close to home for me. So this is something part of Zoe Chrysler's master's thesis, and she published this in 2015, where she's looking at movements of ipswich sparrows when they depart Sable Island. So what do the birds do? Remember that question, how do we know where the birds go? Well, where do the birds go now? Now that we know how we figure it out, what are they actually doing? Well, they sort of looked at the geography of the region. Nova Scotia Peninsula, Sable Island's a remote island, and their wintering grounds are all along the Atlantic coastline, as far as North Carolina. So they wanted to know how they got there, and they sort of came up with, based on the geography, what kind of strategies those birds might take. There's the safe route, which is just taking the land, not crossing water as little as possible. Obviously, you have to cross water to get to the mainland, but once you're there, you can pretty much stick to the land pretty closely. But that's going to take longer. As you can see, the green line here, which is the safe way, it's longer path than the route B, which is in the middle. And that's where you just, as soon as you hit the mainland on route B, you'd go and jump across from the southern tip of Nova Scotia to Cape Cod. And that would be faster, right? So that's a faster route. But if you are to jump across from Bon Portage to Cape Cod, you're going to have to cross this huge body of water. There's no place that you can land there. And you also you can't see land. So you have to have a pretty well established navigational skills to get there. And then the final route is really the I don't care, I'm just going to make it as fast as I can get there kind of route, which is flying directly from Sable Island to wherever they are going to winter without touching land at all. And this is doesn't really seem to be a whole lot more efficient than the route B, the blue line. So it's thought they probably wouldn't take that, but adults are probably more likely to take the water-based routes versus the young birds, because if we think about it, adults, they've already done their migration once, so they're probably somewhat familiar with the land, at least more confident with their navigational skills. Whereas young birds have never left the island before, so perhaps they're less willing to take risks, or less likely to take risks. So what did they find? Well, yeah, indeed, adults seem to take a lot of those overwater flights. And in fact, there wasn't really much evidence that they took that first route, that safe land-based one. It seems like pretty much all the adults jumped across the Gulf of Maine, taking that route B, which is quite interesting, because when you look at the young birds, there's quite a different pattern arising here. There's quite a lot of those birds are detected on stations near that Maine and New Brunswick border. And you might notice there's no stations around the perimeter of Bay of Fundy. So we don't know if the birds went there, right? So keep in mind, these lines aren't like actual paths that the birds take. It's just connecting the dots between which stations they're detected on. So for those young birds, they very well could have gone around the land-based routes. We just don't know exactly if they did that. But at least we can say they did take a more land-based route. They didn't jump across that huge gap of Gulf of Maine as often, and they're more likely to go around that shorter or that longer, more land-based route. So that's one of those questions that, like, this is not like definitive sort of like this is what's happening, but this is more like exploratory stuff where we're trying to figure out, like, we don't know what the birds are doing. We never did. So this is really new kind of information that this first time we're able to be able to see this. So that's why this is kind of exciting technology. But we can go further. Sydney Bliss actually looked at Ipswich sparrows as well. She just published her thesis this past spring, but she was looking at the spring migration and the survivorship in particular during the spring migration, because it's thought that there's a lot of mortality occurs during that time of year. So she wanted to know, like, where is that happening? Because this sort of helps inform conservation, right? In the end, like, what is this all for? Well, we want to know where are these negative impacts occurring, and what we can see here is that she has split up their range into these sort of blocks of geographic regions. And she decided she wanted to compare what was the probability of one showing up in the next block and what was showing up in the next block, and sort of creating this survivorship based on what was the likelihood of it showing up in that next block. And what she found was that there was a very similar kind of survivorship or likelihood of being detected in each block except for block E. So block E is that one on the eastern shore of Nova Scotia, right before they tend to go to Sable Island. It appears that the survivorship drops significantly there. And that sort of would come, logically, you could think about it, when they're doing their spring migration, they have to fly from the mainland to Sable Island, which is kind of a narrow sandbar hundreds of kilometers out in the middle of the Atlantic. So they have to have a really accurate compass in order to spot that. If you've ever been there, flying up to Sable Island, it's actually really hard to spot. Even on a bright, sunny, clear day, you have to be pretty close to it before you can see it. So this is this is definitely thought of as one of those big challenges for the birds. Unfortunately, she didn't have enough data to tease out whether or not it was young birds that had lower survivorship versus adults or something like that. But she could look at what direction that they were moving when they left the mainland to sort of get an idea, was there a difference? And in fact, there was. That young birds seemed to navigate more southerly than adults who were a little bit more easterly than them. And that maybe that means that the young birds were, not navigating to that well, and that's why they didn't make it there as much or something like that. This is, again, just exploratory research where we need to always do more to really say more definitive things about it. But it at least provides us a lot of insight into what might be going on and where next to look. So yeah, I just wanted to show you this map too, which is a nice little visualization that you can create with these kinds of data. This is all data from the fall of 2015. It wasn't used in either of those papers that I've shown you, or yeah, no, none of this data was used in either of those papers. But these are Ipswich sparrows migrating. And remember, those aren't straight line paths. That's just where the birds happen to be detected, but at least gives you a rough idea of what the movements those birds are making. There's also obviously all kinds of interesting shorebird research that's coming out of Julie Paquette and Diana Hamilton. They have done all kinds of great stuff. And unfortunately, I haven't had the time to go into it deeply here, not only because it's outside of my comfort zone, but also it's just the limits of the talk here. So I encourage everybody who wants to look further to look into their research, because they've produced some really incredible stuff. Yeah, it's also quite relevant to Cape Jourimain, as they rely heavily on the stations around that region, and they're tagging quite close by. So some of these challenges involved is station upkeep. And imagine in the Atlantic coast we have hurricanes like we just had here, so they cause a lot of damage. Dorian last year completely destroyed 10 of them. But we also just have that general wear and tear. These stations have been around for 5-10 years, so you get a lot of that salt spray corrosion and stuff. So it's a big pain. It's costly, time consuming. So it's not without its pain, its growing pains, but it's still a really great technology, and it doesn't mean that we shouldn't do it. We just have to keep working on improving it. And so another great resource that's come out of this is this education program that my colleague Liza Barney came out with last fall. I helped create this website with her so that we can sort of showcase what she's produced. But it's basically an AP style school program it's all about MOTUS in bird tracking. So I think this is really a timely thing because of the pandemic. A lot of parents are choosing to homeschool their children. Other parents just they can't send their kids to school, so they're looking for a lot of resources. And this is something that I think is a really great one for people to look at. It's designed for all sorts of different age groups, so lots of resources available online. And actually, it's just kind of fun to look at, even if you're not a student. So I encourage all of you to take a look. It's at motus.org/education, where you can find it. And we have a lot of resources online that I've been working on improving. It's a lot of information involved with this technology, as you can imagine. So doing all this takes a lot of steps in figuring out what you need to do. But if any of you are all interested, I'm always happy to talk about it. And there's a lot of resources online. I encourage people to look at if they have an interest. So moving forward, we have a lot of stuff that we have on our plate. We want to improve the website, make it more user friendly. Right now, there's a lot of information that is out on there, but it's not as easily accessed as we'd like it to be. So that's where sort of our next step, and hopefully the next year we're going to have some kind of product out that will be more of a great sort of dashboard for people to explore the data with. And then there's also a lot of expansion of the network. It's constantly expanding, but the folks in the Northeast here in Pennsylvania, they always have amazingly ambitious projects where they put out 40 or 50 new stations in a given year. And this has helped creating these receiver grids where you can get these really interesting detections across large areas. Lots of sort of, landscape scale movements, which are really, really impressive. There's also a lot of potential expanding into the north because of these are automated receivers. We can set one up to be stationary and set up in the north and just leave it there and collect data for us remotely. Just what briefly is COVID. Like I mentioned earlier, some things have been, there are some issues with that. There's, our regular spring checks have been delayed, but we managed to get things up and operational for the most part on time. Some projects were canceled, unfortunately, and we still have to continue to adapt as rules change. Like, we don't know what's going to happen this next year. So, and in the States, it's been particularly challenging. So a lot of our work is coordinating among partners to make sure their receivers are operational, that they're downloading their data, and things like that. So yeah, with that, I'd like to have any questions and see if there are questions on the question board. So yeah, if any of you do have questions, just put them in the question section here on the website.
Yeah, absolutely. Fantastic presentation, Lucas. Really interesting information there and great data that you and your organization are collecting. So just as we wait to see if anybody has any questions, I have a question.
Sure.
I'm just wondering, how exactly the data is being used. So for instance, if you notice that quite a few of birds in a certain species are being lost in a given geographic area, are there efforts to identify why that may be, or to reach out to, local, governments or municipalities to try and coordinate efforts to resolve that?
Yeah, I think there's one of the challenges with that is sort of saying what a loss is, and if that really is a place where the birds have been dying. So when there's something like the Ipswich sparrow research comes out, we need to look at also like we need to look a little closer and say, like, is that actually what's happening? In that particular example, there was actually an Ipswich sparrow. There's 3 carcasses were found in that block E that I had mentioned, and there was a very exhausted one that was landed on a supply vessel out just off of Sable Island. It was a tagged individual, so it was seen there exhausted. It actually took off at one point, but it was never detected on Sable Island, which sort of tells us that, well, it probably died. It didn't ever make it there, right? So there is that sort of ground-based evidence, but it's still fairly anecdotal, and we need to have more of that research being done. A lot of this stuff, like I said, is exploratory. We're really trying to identify these critical locations, and so that we can take a closer look. And one of the things that Julie Paquette and Diana Hamilton have done, which is really wonderful, is sort of with their shorebirds research, is sort of identify these critical foraging areas for semi-pollinated sandpipers and other species that, as we know, come en masse in like a huge proportion of the North American population comes here in the fall. So if we know where they are, we know which areas that they most heavily rely on. So that there are some of those efforts being put in place to protect those stretches of beach. But again, it's all about collecting more data so we have a better idea of what's happening. Okay, so I see a question here in the chat. I'll answer it first from Laura Tranquilla. And so there's, thanks for that one too. As a good point I should have brought up. And it's basically what is the importance of placement for individual stations. In other words, are there some geographic areas that are more key than others, and how does the station nearest to Cape Jourimain, i.e. along the eastern New Brunswick coast, fit into the larger picture? So we do have a station quite close to Cape Jourimain. It's in Anne's Acres, in that sort of cottage area, and it's actually quite vital because these sort of like headlands and coastal areas are where animals tend to migrate along. And so we think about somewhere like Cape Jourimain, it's so close to PEI that we can sort of we can point an antenna directly towards PEI. They have about a 20-kilometer range, so that anything passing between New Brunswick and PEI will be detected. And Cape Jourimain is such a prominent spot that it really will have a higher probability of detecting birds than, say, Anne's Acres, because of the prominence of the location. Anne's Acres is a little tucked into the coast, the cove there. So those sort of headlands are really important, and yeah, for studying these shorebirds, but also passerines as well. And then we have one more question here, Cheryl Thomas in the Q&A. So they ask, do the monitors eventually fall off the birds, and how are they attached? So the radio transmitters do fall off the birds eventually. It does depend on the attachment method. So one method is for bats that are used quite largely is suturing. They also use this sometimes on certain seabirds and other birds that you have a hard time attaching in other ways. And suturing is basically just like using stitches. And there's been quite a bit of research done around that seems to show that it doesn't have that much of a deleterious effect, which is why we can do it. And those stitches actually dissolve over time, and the tag will fall off. So that's sort of the most invasive method. And just so you're aware, like, we don't really want to be negatively affecting these birds, not just because we don't want to harm them, but it also, like, it affects the data that we get from them, right? So we're not really, if we are harming them, we're not going to get a true movement of those animals. So that is important to us. The other methods that are used more widely is glue-on methods. So you just use some epoxy and stick it right onto the feathers or the skin, and when they shed those feathers or the skin, it falls off with it. And so that usually is like a year or less, depending on their molt cycle. And then the final method, which I've used more widely on passerines, is the figure-8 leg loop harness, which is a stretchy jewelry elastic that you make a little backpack, and it goes around their legs. And that is made out of nylon and super glue, and it falls apart in the sun. And it just falls off within a year for the most part. And sometimes they retain for a little longer, but those tags do fall off as well.
All right. Well, thank you, Lucas, again. Really interesting presentation. I actually had the opportunity to live on Sable Island for 3 months back when I was doing my master's program, doing some research for Parks Canada. So really interesting place. And of course, the Ipswich Sparrow, which I'm fairly familiar with. So thanks for giving us some insight on that. If anybody is interested in learning more about Birds Canada or the work that they do, then I have posted the links to their website and social media in the chat room.
All right, thank you.
All right, thanks. Bye-bye.
Bye.